Okay, so I want to kick off this lesson for this unit. So I want to play a game. I love games. I love problem solving. Okay. So way back when I did computer science and I wrote computer programs, it was a lot simpler back then, right? So what I'm going to do is I'm going to emulate a program that I used to write. And with computer programs, what you have is, it's even like today, you have an input, so you input something in the computer program, and then it gives you an output. So like the answer, right? So the challenge is for you guys to figure out what the program is doing. All right? So who wants? So the only input that's allowed is an integer between 0 and 10, including 0 and 10 as well. Okay, so it's between 0 and 10 inclusive. Integer, that's what the valid input is. So who wants to start off with? Integers. Between 0 and 10 inclusive. So if you add 0, you can add 10. Okay? So who wants to do the first one? Who wants to give me the first input for the computer program?
Got this.
Abby.
4.
4?
Do I get to write on the board?
You want to come around the board?
Yeah.
Alright, sure. That works too.
Yeah.
4, that's okay. Gives me time to do my computation.
Huh?
My computation.
I thought the computer was doing it.
No, I'm simulating the computer program.
Oh. Now what do I do?
Okay, that's it. No. So the input is 4, the output is 11.
I thought it was just 0.
Okay, take these notes down too. Okay, pick up paper, write down these notes. Yeah, just draw a table. You don't have to actually draw a table. Just have the 2 columns. Okay. So who wants to put up another input? Andrew. You want to come up? You want me to write? No, I don't. I'm going to have extra paper to lend Michael. And Max.
You have great.
Oh boy. This is a class ready for lunch too.
Yeah.
I think now one time we spent getting paper during class, you guys owe me after lunch, after the class. So sorry, Andrew, you said 3?
Yeah.
Yes?
Yes.
Okay, the output for this one is 9. Write it down. So this is what the computer program's doing. The input's 3, the output's 9. Anyone else? Aaron.
Times 2 plus 3.
Can I write the number?
Sure, go and write the number. Eight. 8.
19.
19.
19.
Okay, yeah.
Yeah.
Okay, one last number. One last input for this computer program. Matt. 2.
9.
How did you die? 7. Okay, now I want you on one of your graph papers, take this and just plot it. So just do a scatter plot. So here, what is our independent variable? The input, right? And what's your dependent variable?
The output.
The output, right? So here we have a relationship between two things, the input and the output.
How do you want us to plot this? Like, what
Mr.
thing?
Chair,
On the whole graph?
are we allowed to graph those to go up by two?
Go however you like, right? Obviously, this one's not gonna work for me. I'm gonna change the scale on this. So instead of 4, instead of 2 be 4, 8, 12, 16, and 20. Negative 4, 8, 12. So just do a scatter plot of those numbers. So we have 4, 11. Sorry?
I'm supposed to use the numbers.
Yeah. So your independent variable is the input, and your dependent variable is the output. Right? Your output is dependent on the input. The input affects your output. So we have a correlation here, hopefully. You're just doing a scatter plot here, right? Review of last unit, just doing a scatter plot. Independent variable, dependent variable. So what type of relationship do we have here? Positive trend. Okay. So I see Brian here, he drew a line through it. Did I ask what line of incident? I just want a scatter plot, right? Just a scatter plot, just want to see those thoughts. What else can we say about this relationship? There's an outlier.
No, never mind.
It's linear. It looks like it's linear. We only got 4 pieces of data, so it's kind of hard to tell. Okay, let's try another example. Okay, so here we have another computer program. Okay. Who wants to do an input? Who wants to give an input? Okay, between 0 and 10 again. Brian. Five, sure. Sure. 5. 5. Okay, who wants to give me a second input? Huh? 1?
Yes.
Okay, so this is our table you're creating. Okay, a third input. Veronica. 10. What about the third? Give me one last one.
It's 2x, 1
Who wants to give me the last one? Aaron?
7.
7?
14.
Who's the computer here?
Yeah, isn't it times
Is
itself?
it 14?
Like, no,
Yeah.
not times itself, but like, just add.
Times
It's times 2. 1 times 1 is times
2 times 1 is 2.
If it's times 1.
Okay,
one.
so same thing. Take this set of data and plot it.
So use the next graph, right?
So use the next graph over, right? So we want to plot the points 5, 10. So again, our independent and dependent variables are still the same.
How would you?
Do it on a different one. Sorry, Michael?
How would you plot this?
Sorry? So I'm going to do this really quick on this other one. So 4, 11. Three, 9.
Use it.
9, 15, 17. 8, 19. Okay, so those are the 4 dots for the first graph. So the next one, can somebody just read out the coordinates for me? So I don't have to go back and forth.
5 and 10.
5 and 10,
That's 7 and 14.
1
7
and 2.
and 14,
And 10 is 1.
1 and 2.
1 and 2,
And 10 and 20.
and 20. Okay, how about we describe this relationship? Positive still, yeah. Linear, still looks like it's linear, yeah. Okay. Let's go through our third example.
Are the inputs still 1 to
0 to 10, your inputs are still 0 to 10.
Make it really hard.
Make it really hard. I don't know if we can do that.
Level up.
Okay, so what's an input? Math, 4? So 4, and I'm going to do this, it's going to weird, I'm going to do this to make actually. 4. So the input's 4, the output's 9. Right. 1. 1. What's another input? Tyler. 6?
0.
6? Any guesses what's going to be?
15. What?
Where? How? What's the pattern?
Times.
Oh!
Yeah.
One last one.
That's what I was thinking.
One last
No, I
input.
was actually thinking that.
One last input.
I was thinking that. This one.
Oh,
2? So 2 will give us,
Oh, yeah. I got it.
okay, so likewise, plot these numbers in our scatter plot. Somebody read them out for me. 4, 9, 1, 0. So 4, 9 is here. 1, 0 is here. 6, 15. Right here. Oops.
2 and 3.
And 2 and 3. Okay, one last example. All right, here we go. Who wants to start us off with the input? Andrew?
7.
7?
Yes.
Okay. No, the input has to be. Oh.
So 7, my output, for input of 7, my output is negative 11. Any other numbers? Any other guesses? Veronica? 9? Two? Two gives us
Oh, no, Joe.
right now. Do you not have paper? One last number. One last input. 10? Okay, so likewise take these and plot it. Because 7, negative 11. What else do we have?
7, negative 11, 9, negative 15,
9,
2, negative
1. Sorry, 2, negative 1?
Yeah. And 10, negative 17.
Okay. So how would you describe this trend? Of these ones. Is there a correlation here?
Negative
Negative trend? Okay. So I noticed that you guys were able to start predicting, start guessing what numbers this computer program was outputting. What was the algorithm that you guys were doing? What was the formula? How is it you were able to predict? So the first one, how is it that you able to predict what number it was? How is it that you able to predict the input? I'm sorry, the output.
Times 2 plus 3.
Sorry, Matt?
Times 2 plus 3.
So here we had the output is equal to the input times what?
2
Times 2
plus 3.
plus 3. Okay, we see that pattern there, right? What about this one? How did you guys determine the output? Right? Input times 2. Output is equal to input times 2? So 2 times the input. Okay? For the third one, what was going on there? There?
Input times 3
output was 3 times the input minus 3. Right? Finally, on the last one, what was going on? Veronica?
It's a -2 input plus 3.
Output was -2 multiplied by the input
Plus 3.
plus 3. Okay. So we started to see a pattern or seeing a trend. I think it was pretty exact, right? We could predict for sure what number it was. So I have some questions about this. So what do you notice about the relationship between the input and output? We answered this already. Let's write some of that down. So what's the relationship? What's the relationship? So the input affects output. So that implies the input is independent.
Yeah.
Output is dependent. Okay, what else? What else do you know about this relationship?
The higher the input.
Well, think about what we talked about last unit. We talked about trends. Right? We're trying to analyze the scatter plot. Is it a curve?
Linear.
So it looked like it was linear. Right? So positive, negative?
There's one positive, no, 3 positive, 1 negative.
Right. So it was either positive or negative. So both positive or negative. Anything else? Well, the fact that you saw it was linear, was it weak or was it strong?
Strong.
Right, it was strong. Right, it's a strong correlation. Okay. So I restricted your input to be just between integers between 0 and 10. Right? What would happen if I expanded that restriction a little bit and said, you know what? I'm going to allow you any number now between 0 and 10. Any number, decimals. Any number. What would happen? What would happen when we start plotting this?
It'd be really messy.
It'd be really messy. How come?
Because there's like an infinite amount of numbers between every number.
There's an infinite amount of numbers between every number. Wow.
Between
That's
every
hard.
whole-
That's, no, I'm sorry. That's really hard for me to grasp.
Like, between every whole number is an infinite amount of decimal places because you can just keep adding zeros in front of them.
So yeah. So basically, it's a whole whack of points we can plot.
It's not very accurate.
Well, on this scale, it wouldn't be very accurate, right? But what would happen? What would it look like? What does this thing start to look like? But let's say we can try to do this. What would it start to look like?
Yeah.
They're really close together.
Yeah. So we start putting those dots, those points, really, really close together. So that's what we're doing. We're just plotting like a million points, right? What we're gonna see is what's gonna happen. So bear with me. I haven't tried this before. So let's say with the red line, if I took this, oh, no. So So I took it from here. Oh, that's really thick. That's not what I wanted. Let's try this again. Lines.
Can't really choose.
Oh, let's choose that. There we go. Going from here to that one, right? That's what we would get if I was to plot every single line around them. If I took the green and did the same thing, so here's my first one. I was off a little bit. It'll start looking like that. If I took my blue, it'll look like that. See if I can change the colors on these. If I took the black, okay. So if I was to take between 0 and 10, actually if I extended these lines, so basically my x is between 0 and 10, I was to plot all those points, that's what it will look like. Okay? It will look like a line. Okay? Is it really a line?
No.
Okay? Not really. So that's why I want you to start thinking, even though we call this linear, it's not really a line because as Matt said, there's an infinite amount of points in between. What we could do is, but we do understand there's a relationship between input and output now. Okay? So the next question I have is, what will happen if we allow any possible values now? So I'm not restricting you between 0 and x, or 0 and 10. Any number you can have. But what happened?
Let's start with a straight line.
Well, what happened? Is that line going to look any different? Tyler?
The line would look the same, but then the graph would have to keep on expanding.
Yeah, so basically we still have the same line. What happens is the line is just going to keep on extending. On and on and on and on. Okay? So what do you think you have your rulers for? We want to do straight lines through these points because we know that there's a linear relationship there. Okay? Any questions on that? I'm driving home this point because what I'm discovering when I teach my grade 10s is they don't have that connection between the input and the output. The independent, the fact that it's affected independent. Okay? So here's a question that's sort of related to this. This allows us to predict. If we know that things are behaving linearly, it allows us to predict things and allows us to do certain calculations. So here, Dean gets a part-time job at a nearby Tim Hortons. He earns $11.50 an hour. How can we determine a calculation that determines Dean's pay? And how can we graph this? So if he earns $11.50 an hour, how can we determine a calculation to calculate Dean's pay? How can we calculate this? Veronica.
We make the input output like table, and then
Okay.
since the time like is dependent variable, it would be on the input side, and then the amount of money he makes per hour is on the output side.
Okay, so here we're going to hit input, which is hours. Right? And here we have output. So this is what you're saying?
Yeah.
So output would be what?
How much he earns.
So pay is paid.
Yeah.
Okay? And how would you carry forth with this? So 1 hour would be how much? How else?
2 hours.
2 hours,
Light green.
23. Okay. 3 hours, 34.50. I don't know where that came from. Okay, do we see a pattern happening here?
Yes.
So what might be an equation? What equation can we come up with? So instead of using the words input and output now, let's use what they're actually representing. What kind of equation can we come up with this now?
I don't understand.
How can we come up with the equation to determine Dean's pay, given that he gets paid $11.50 an hour? Okay, so what's the input here?
No,
So what's the output?
well,
Well, what do we call it? Pay, right? Is equal to sorry, what times hours? So we're multiplying by hours.
your pay.
Well, his pay determines how many hours he works and what?
How much you make? Yeah, you make 11 times.
Right?
Right times 8 hours.
So we have H, but we have to multiply by H.
1150.
$11.50, right?
Yeah, that's what I meant with pay.
So here his pay is determined by $11.50 times multiplied by the number of hours he works. Okay? So how can we represent this graphically? Well, if I was drawing axes, so you put things on another grid. So here is my independent variable is hours. Yeah. And here my dependent variable is pay. So number of hours affects how much he gets paid. So here I'm going to do a scale, 1, 2, 3. Here I'll do 1, 1150, 23, 2450, 3450, sorry. Okay, so how will we plot this? We got 0, 0. So if he's not working, he's not going to earn any money. $1 gives us $11.50. $2 gives us 23. There's 2 hours. 3 hours gives us 34.50. So here I just use the convenience of a scale that's intervals of 11.50. Now if I was to graph this, it looks something like that. I have absolutely no idea. It used to be $3.75 in my first job. Things have changed a lot since then.
I know. Well, back then, when you
Okay? But here, what's the benefit of our equation? What's the benefit of having this equation? What does this allow us to do? Veronica? Yeah, remember the whole idea of interpolation, extrapolation? Right? It allows us to give us an estimate. In fact, here is not even an estimate, it's an actual prediction. That value will be correct. So here, 1 week, Dean worked 15 hours. What was his pay for that week? How do we calculate that?
15 times.
Sorry, what did you say, Michael? So pay is equal to 11.5 because that was his hourly rate.
Oh,
That's
you have to take
funky.
off.
No, I have to go back to pens. It should do that automatically. So pay is 1150 times 15. So what is that equal to? Calculators? 15 times 150? 172.5. So therefore, Dean earned 172.50 for that week. Well, if you get a job that pays that much, yeah. But 15 hours is pretty long. Right, it's 3 hours a day if you work 5 days a week. I can't even guys get you do homework for half an hour. Don't tell me 3 hours is not bad. Not different. Not different whatsoever.
Everyone would rather homework. Yeah, exactly. When you work at Timmy's, you need like all those people. Exactly.
Irrelevant.
He's annoying.
No.
You guys can find half an hour to do homework. That's all my point is.
Homework on the job.
You work your weekends, right? That's what?
Yeah.
Saturday and Sunday, 8 hours? That's not bad.
That's pretty bad. Like volunteer hours, you can do that.
That's pretty bad.
I don't waste my weekend. I waste my
Yeah, you're right. I think you spend your weekend doing math, right? Yeah. I hear you. Okay, so here's this. The following week, Dean earned $109.25. How many hours did Dean work?
He didn't work. He worked less than.
You can
Well, like
divide.
he worked for a couple and a bit.
Well, he worked less than 15. I think that's what you're saying,
He
right?
worked less than 15.
But now that we have an equation,
9.5 years.
Yeah.
right? We know the exact relationship between hours and pay. We can actually calculate this. So how can we calculate how many hours he worked?
109.25 divided by 11.
Okay, that's how you see your head.
Yeah.
How can we work this out algebraically? Ideas? Ideas, sir?
Oh, is that like the 1150 times x? equals,
Well,
2 by, and then.
what's our equation? Okay. So I'm gonna use variables now.
11.
I'm gonna use P is equal to 11.5 times H. Right? So pay is equal to 11.5 times the number of hours you worked. Well, do you know the number of hours you worked?
No, you know the pay.
We know the pay. So we go 109.25 to 11.5 H. Oh my gosh.
It's these again.
No!
Divided by.
These things again called solving equations?
Too hard.
No. You guys did so well in that test, right? How is it that I isolate for H? I want to solve for H.
Divide.
So that's, remember when I said way back? Doing the equations, solving for equations? Most important thing that you'll learn in grade 9. This is the second one, learning linear equations. But it all comes back to you need to go solve equations once we get to this point. So how do I isolate for H? So that came back to how Matt got his original answer of taking 109.25 divided by 11.5. So what's H? 9.5 hours.
Yes.
So therefore, Dean worked 9.5 hours. Okay?
9.7.
So the nice thing about once we have an equation is you don't have to work an exact number of hours, right? You could get billed by the second almost. Every second that I work, I'm gonna get paid. I worked 9.56432948 hours, right? And if the company says, well, if you can actually measure that, it's exactly how much you worked, will pay you exactly that amount, times 150, right? So that's the nice thing about equation is that once we have that, our numbers don't have to be so nice anymore for us to get that exact value. Okay, the exact precise number, that's the answer, the output. Okay, any questions on this? So one other example I want to give quickly. I used to have a cell phone plan. My very first cell phone plan. Guess how much it cost me?
$10.
Actually, it wasn't too bad. It was a really good deal back then.
17.
How many texts? $1.
20. Oh, I was $20, guys.
20
Oh,
bucks.
that's-
It's $20 a month.
That's a
Okay.
good deal.
I know that's half a month.
By the way, these are examples I'm doing. It'd be good if you wrote them down as part of your homework. Glad you're entertained by the writing.
What can we just rewatch?
You could rewatch a video, but you're not gonna have notes though.
Wait,
But
can
you
we
can
write
write
it
it
down?
download the video.
You're gonna watch every single of my videos before your exam. I'll power to you.
Alright, I'll do that.
Well, I don't know how long this lesson been already. Half an hour.
It's gonna be like.
Yeah, but can you like skip?
Yes.
So this is why I'm against doing the videos because of attitudes like that. Right? Oh, it's online, it's on the web, it's available, so I don't need to do any work in class. That's not the reason why I'm doing this. Ish. So back then it was $20 a month. It was actually a pretty good deal. I got 100 minutes of talk time, actually billed by the second, which was rare back then, right? So it's a pretty cool cell phone plan, right? Back then though, the problem was they didn't have texting. Right? Just call, we just talked, you know. The old thing they used back then, talk to one another, right? Know what a person's voice sounds like. You know, hear emotion and intonation. You can tell if I'm actually joking because I'm laughing, or if I'm actually mad because I'm yelling. You've never ever put a smiley face when you're not happy.
Yeah, obviously.
Yeah, when you like don't know what to say and you don't want to argue.
Or just
like,
write
put a happy
Oh, that's okay if we don't go through this.
a happy
Face.
face.
Happy face.
Yeah, you should do the crying face.
Right? So back then it was $20 a month. Didn't have any text. But you know what? I was fine. And then all of a sudden texting got huge, got popular. And because my plan didn't have a texting thing, people would text me and I would get charged. Because there was nothing in the thing, right? There's nothing in the laws, right? All of a sudden, one day the government says, or somebody says, well, you know what? We'll just charge people 35 cents a text. Right? You're not under a plan. And I'm like, whatever. I don't text anyways. I don't care. The problem was, people started texting me.
Yeah.
And then you
So it cost me 35 cents when people texted me.
So what if someone spams you?
That's the thing. Someone spams me. I'm getting charged. I was upset. I was like, what kind of plan is this? I never agreed to this. It's like, you know, I don't know what happened with the teachers right now. I never agreed to this contract. But yet, it's being forced down my throat that every time I get a text, even though I never asked for it, I'm getting charged.
It's like 100 texts.
Right? So here, I get charged 35 cents per text. Okay? So my bill is just $20 a month just for me to talk, and then I get charged 35 cents for every text. If I get 10 texts, how much is my phone bill?
$23.50.
Sorry?
$23.
How'd you get that?
$20 a month and you got 10 texts, so 35 times 10.
So you got, it's $20 plus 10 times 35 cents?
Yeah.
Does that make sense?
Yeah.
Yes? 10 texts, that's 35, so it's basically 20 plus 350 is equal to 2350. What happens if we get 12 texts? What happens if we get 15, 20, 36, 92?
92.
It'll be pretty bad.
What kind of equation? How can I come up with an equation for my phone bill? So here my bill is equal to what?
20 plus 3x.
20 plus
20 plus
0.35.
0.5
So I'm not gonna call x.
X. T.
Let's T for text. Right? So my phone bill is actually $20 plus the number of texts I get, which is T, times 35 cents, 0.35. So how can I represent this graphically? So let's keep this as my scale, 0, 0. I'm actually not gonna keep this as 0. So here, what's my independent variable?
the number of times per day.
Right, the number of texts, because that's going to affect my phone bill, right? And here's my phone bill. So here I'm going to start off with 20. 20, and let's just say I go up by 21, 22. And here the text starts off 0, 1, 2, 3. Okay, so what will my equation or what will my line look like then?
It wouldn't really be very steep.
Well, if it's 2 texts, how much is it?
28.70. $20.70.
3 texts? It's almost $21.
No, $21 less.
21, so just over 21. Right? So here if I went 6 texts, it'll be just over 22. Okay. So you see what I'm doing? I'm just finding 2 or 3 points. Doesn't have to be one right after another. Any 2 or 3 points that fits my equation, and then I just draw a straight line through these. So here's an equation and how it's graphically represented of my phone bill. So here's some questions. How much of my phone bill cost? If I had 22 texts in a month, how much would that cost?
27.
So bill is equal to 20 plus 0.35. How many texts do I have?
22.
How much is that? 27.70. How much for 49 texts?
37.
20 plus 0.35, 49. So I have 49 texts now. How much?
37.15.
37.50. Holy smokes. What happens if I average 40 texts a day? 40 texts a day isn't that bad, right?
It'd be really bad.
10 friends, 5 texts a day. Remember, this is to and from.
Okay.
So when I go,
$440.
yo, or I can go, some a friend messaged me, yo,
So.
like, what? What's up? Nothing?
LOL.
Then he
Same.
says, what?
Okay,
No, it's not even okay. It's
Then you
just
say,
okay.
okay, right? Isn't that how a lot of your text dialogues go?
Yeah, it goes.
Hello,
We do like paragraphs
Nothing.
of love.
How about you?
Wow.
Nothing much.
It'd be $440.
That's great.
So how many texts would I have in 1 month then?
That's it.
120.
Well, I average 40 a day. Well, how many days in a month roughly?
30.
30.
It's 1,200.
So 1,200 texts in a month, which I'm sure some of you could actually achieve.
Yeah.
How much did that bill cost me?
$440 plus your,
Woo.
$440?
yeah, plus your phone bill. 420 without.
What?
Also $460.
No,
it's
without,
420.
with only text it's 420, but with
Oh,
your
okay.
phone bill it's 440.
Really?
Yeah.
Oh, that's
Yes.
Oh, these people didn't know.
That's what I did once.
Calling,
Yeah, I got a lot of trouble.
Okay.
Yes.
So, question. I could actually along here try to pick out if it's 4 texts, how much it cost me. If it's 8 texts, how much it cost me if I look into the graph. Why is that not convenient though? It's not accurate. Why else? Well, can I actually find 1,200 on this graph the way I've done it? No, right? So now I can start looking at it, extrapolating, interpolating, based on things that aren't even on the graph, that I can come close to the graph. Okay? So here we have the power of equations. Alright? So here's another question. My phone bill 1 month was $22.55. How many text messages did I do that day, or that month? How can I figure that out? What was my equation? What was my equation? Right, my bill
7.
is equal to 20 plus 0.35 t.
You have 9 texts.
Right? I don't know what t is, that's what I'm trying to figure out. But what's my bill? 23.55?
You subtract 20 and divide
Right? Again, so here I'm solving for t. Right? So we start off with 2 variables, independent and dependent. We're given information about one, we can solve the other. Okay? So how do I solve for t here?
Subtract
No,
Don't?
Minus
No, subtract 1.
Well, this is
Oh,
0.35 is multiply my variable. What do I need to do first though?
Minus 20.
Yeah, I can subtract my 20. So I'm left with 255 equals 0.35 t,
22.
right? And then divide both sides by 0.35.
Yes.
You're
What's
oh,
that?
you're-
It's
um,
like
it's
7.285.
No, it's 20, it's 2 million live, so it's not. It's
So 9.
255 divided by
Right, so I just texted 9 times.
No, it's
Not like 7
Yeah,
and
7.
What?
7.285.
2.55 divided by 0.35?
Yeah, it's like 7 and 2 over 7.
Oh, did I use the wrong numbers? I might have made a typo. What's 9 times 0.35?
3.15.
3 point, oh, I know what I did wrong. I assumed it was, back then I assumed it was 50 cents a text, not 35 cents. You guys told me it's 35. So this number should have been, sorry, what's 9 times 0.35?
3.15.
3.15, so that should have been 23.15. So that should be in the original question. My phone bill was 23.15.
So it's 15 cents?
Did you know they charge you for calling
I
that?
thought it used to be 15 cents. Didn't it?
Yeah,
It's like, it's a lot because, yeah, when I first got my phone, I didn't have texting plan at first because.
Now you know why some parents are paying like out the wazoo for the kid's phone bill because they didn't have a certain plan. Because it adds up.
That did research.
I have a texting plan.
Gotta do research. You know what? Hopefully in a couple of months, you can actually figure out which cell phone plan is best for me. I'll give you some information.
Oh, I can do it right now. What do you do?
Okay, so take down these notes. So introduce some key concepts that we need to know. So one thing that I introduced, I didn't define it, was called a direct variation. A direct variation. So that's a relationship between two variables in which one variable is a direct constant multiple, known as a constant of variation of the other. And here the graph passes through the origin. So in other words, one variable is just a multiple of the other. So an example, that was a computer program that was just 2x, 2 times the input. The other example was Dean working at Tim Hortons. Right? That was just a straight direct variation. The other thing that I introduced was a partial variation. So it's the same as a direct variation, but there's an initial or fixed value. So in this case, the graph does not pass through the origin. So in the computer example, it was basically the other 3 examples then. Those were partial variations. And the cell phone example was another partial variation. The cell phone example, what was the initial value? 20, right? It had that initial value of $20. So finally, the equation of the form y is equal to mx plus b models both direct and partial variation, where m represents the constant of variation. That means how many times is this thing being a multiple of, and b represents the initial or fixed value of y. So essentially when the b is 0, a direct variation relationship occurs. Okay, so those are the key things that hopefully you picked up out of this lesson. Homework is under the textbook. Okay, so like the equations unit, because this unit is so important, I'm going to be stressing hard, looking for that homework. Then every time Google presentation, I'm going to be tracking it. Okay, question there? Yeah, if you can't, for whatever reason, insert your picture to Google presentation, email me your set of pictures.